today dealing with our spheres and our hemispheres. A sphere, by definition, is a set of all points in a space equidistant from a given point. What do you think equidistant means? Equally distant. Yes, it means all the same distance away from a given point. That given point that they are all the same distance away from is the center of the sphere. This is a very similar definition to circle. The only difference is that circle references in 2 dimensions, a sphere is 3-dimensional. We're also talking today about half spheres, which are known as hemispheres. Now, when we focus in on spheres and hemispheres, the half sphere, so when you cut a sphere perfectly in half, you got your hemispheres, but you also end up with a cross-section of a circle when you do this. That circle, if it goes directly through that center point, if it cuts the sphere perfectly in half, that circle there is known as the great circle. We have to focus in on the great circle a little bit when it comes to our spheres, because the great circle is what gives us our key measurements regarding spheres and hemispheres. Specifically, it gives us our radius, which is the key measurement of these shapes. So R is the radius of the great circle, in other words, the radius of the sphere in general. Those are the same thing. The radius of that circle is the radius of the sphere. Now, when we do that, if we are looking in at our spheres, we're focusing in on just the spheres first. The surface area for a sphere, if I were to take that great circle and I were to lay it out, kind of plastering the sphere in shapes the size of that great circle, I could fit exactly 4 of them on there. So the surface area of a sphere is given by the formula 4 pi r squared. What kind of units go on a surface area?
Squared.
Yep. Do you notice there is not a lateral area? There is no lateral sides to a sphere. A sphere is a sphere is a sphere. That's all you got. Now, volume for a sphere is 4/3 pi times radius cubed. We got our units cubed. One of the most common issues I see with spheres is people mixing up where the squared goes and where the cubed goes. So please be careful with your powers. Now, a lot of you use the square button on your calculators, and that's great and fine and dandy, and I'm perfectly fine with that. Do you remember how to put a power of 3 into your calculators?
Mine just has it.
Some calculators have it. If your calculator does not have a special power of 3 button, look for your little upwards arrow. That is your power button. So if I wanted to say put 5 to the power of 3, type in 5, type in the little power button, and then I put 3. 5 to the power of 3 is 125. So make sure you know how to put a power into your calculator. Some calculators are a little bit different. If you have one that is different, that doesn't necessarily have that, most likely you might have one that looks like this. You do the exact same thing on that one. If you want to do 5 to the power of 3, you would type in 5, you would type in that button, and you would type in 3.
Mine also has the power of -1.
That is an inverse button. That is something completely different. Actually, it might be a power of -1. That's weird to have.
Yeah.
Anyway. Okay. Find the volume and the surface area of each solid. Round the answer to the nearest hundredth. What shape?
I think it's a sphere.
That is a sphere. Be careful to keep an eye on these. Spheres and hemispheres look very similar. Okay, so that is a sphere, which means our surface area is 4 pi r to what power?
Cube.
No.
Oh, no, squared, yeah.
Squared. Volume is 4/3 pi r to the power of? That one's the third power. Do I have the radius of the sphere? We have the diameter. It's pointing to something that goes all the way across. That makes it a diameter. How do we go from diameter to radius again? Divide it by 2, so the radius is 20. So, 4 pi times 20 squared will give us our surface area. 4/3 pi times pi, specifically, times 20 to the third power will give us our volume. How do I put 4/3 into a calculator if I don't have a fraction button? It's just 4 divided by 3. So, 4. I can put the times pi. It's not the end of the world if I don't put the times pi between the 4 and the pi here. Times 20 squared. If you have a fancy calculator, it'll do something like mine. What is mine doing? Yeah, 1600 pi. What is that? It's an exact answer or an answer in terms of pi. If I don't want it to be in terms of pi, which we've just been rounding everything to the nearest hundredth, remember, click your either F to D or S to D button depending upon your calculator. So, 5,026 point 55 what's?
Feet squared.
Yes, it was feet, so feet squared.
Did you not trust me, Miss Benson?
You sometimes answer before your brain engages?
Huh. Never figured that one.
Okay. 4/3, 4 divided by 3 times pi times 20 to the power of 3 is what I want next. Again, if you got a fancy calculator, it might give you the exact. It's a fraction exact. Hard pass. 33,510.32 feet cubed is the volume.
Yeah, I got that one right. See, Miss Benson, my brain's somewhat engaged.
I know. Colin, I know it generally is, but sometimes you just speak too quickly. That's all. I do trust in general.
And your calculator's about to die.
Oh, did it say it was low battery?
No.
Oh no, it just turns off really quickly.
It can die.
Oh yeah. Calculators have batteries.
Well, yeah, but like, I don't know.
Yes, they can actually like go kaput too. I was very sad at the beginning of this school year when my calculator from high school died. Okay. Anyway, second problem here. also a sphere?
Yep.
Yes. Which means I've got those same formulas. Surface area equals 4 pi r to what power? 2. And volume is 4/3 pi r to what power? 3.
Cubed.
AKA cubed. Key thing I need is radius. Do I have my radius?
No.
No. What is it giving me instead?
Circumference.
It's giving me the circumference of the great circle. I need radius. If only I knew a relationship between a circumference of a circle and a radius of a circle.
Yeah, only.
If only there was a sheet of paper that might help us with this. That maybe has circumference formula on it. That should be on every single person's desk right now, unless you've memorized every single one of these formulas. Pi times diameter, that's one option. Or 2 times pi times radius. If I want the radius, it makes more sense to use the 2 pi r one. So, circumference equals 2 pi r, which means 6 pi is equal to 2 pi r. Do you notice there's pi's on both sides? What's going to happen with them? They're going to cancel out, because if I go to divide by pi, they're both going to die a very painful death. Death by pi. Come on, death by pi would be a painful death. Could you imagine a beautiful, sweet treat killing you? That would not be fun. Correct. I know, right? I'm not weird at all. Shh, don't tell anyone. Ignore the fact that I'm recording this lesson. What's the radius? 3. Now what? Plug it in. Going in my drawer as if there's anything that I wanted in the drawer. Nope. Oops. Nate! Head up. I'm not even calling on you yet. First, I've drawn Trayton's name. What do you get for surface area?
I got
113.10?
Is that right?
Yeah.
Oh, sweet.
Technically, I wouldn't call it 0.10, but I knew what you meant. And it's correct. Rounded perfectly. Lily,
Hold on.
units.
Oh, centimeter squared.
Thank you. Elena, what do we get for volume?
113.10.
Interesting.
Same volume and surface area. Wow.
Are they the same though?
Oh, no, because that's cubed.
Because that's centimeters cubed. Now, it does result in the same number this time around. It's coincidental. It's something that can happen with a radius of 3. Because of the fact that the divide by 3 would cancel out one of those 3's, leaving that to be a 3 squared type of thing. It's the only time it happens. So, don't assume this is going to happen every time. It's a rare thing that happens. Okay, we're not going to go through this next problem, but we are going to chat about it a little bit. Is that a sphere?
Yep.
Yes. What is its radius? I'm giving you the radius straight up. So guess what you would do? You would plug it into the formula. I know. Mind blowing. Moving on. We are also talking about hemispheres today. For a hemisphere, you are also going to work with the radius of the great circle. And the radius of the great circle is also the radius of the sphere. Now, surface area and volume, they have a relation to that of the full-on sphere. Again, full-on sphere, surface area would be 4 pi r squared. Volume would be 4/3 pi r cubed. A hemisphere cuts a sphere in half. Right?
Yeah.
So what do you think would happen to these formulas?
Cut in half.
They cut in half. Kind of. There's one problem with that idea. When I take a sphere and I cut it in half, the volume actually will get perfectly cut in half. But the surface area becomes a problem. Here's where I wish I remembered where my sphere was. The surface area becomes a problem because of the fact that if you cut a sphere in half, and you're talking about surface area, you haven't created a hemisphere, you've created a bowl. But to do surface area for a sphere, I'm doing my hands the best I can for the shape I'm trying to make. I need to cap the bowl to create a hemisphere. The cap would be an additional circle. So while we would think this cuts in half, I need to cut it in half and throw another circle on top of it. Cut this in half. You would get 2 pi r squared. Add an additional circle. What's the area of the circle?
3/6.
Pi r squared. These radii are the same, which means the surface area for a hemisphere is 3 pi r squared. Shockingly enough, units are squared. Volume, on the other hand, if you think about it as the amount of water you can fill a sphere with versus fill a half a sphere with, it is exactly half. How do I divide 4/3 pi r cubed in half? If I do divide by 2, what part is the divide by 2 going to meld together with, because it can actually come together nicely? The r, the pi, or the fraction? The fraction. So I'm taking 4/3 and I'm dividing it by 2. How do you divide fractions? Correct. You divide them. But how? Multiply by the reciprocal. Keep, change, flip. Sound familiar? Keep the 4/3, change the divide to a multiply, flip that fraction. Wait a second. How's that a fraction? It's under 1, so if I flip it, it becomes this. All of a sudden, I multiply straight across. I get 4/6. Simplify our fraction, and you get, what do both 4 and 6 divide by? 2. So you get 2/3. Instead of 4/3 pi r cubed, it is 2/3 pi r cubed. Units cubed. So, very, very similar. You have to be careful. Make sure you're using sphere formulas for full spheres and hemisphere formulas for hemispheres. Especially since they look similar. Is that a sphere or a hemisphere? That is a hemisphere. How can you tell that that's a hemisphere and not a full sphere? It is half, but not everyone can tell that it's half. A full sphere, when you look at it, will always look like a perfect circle with an oval in the middle of it. Even if that oval is going sideways and I can't draw a circle, so you pretend that I draw perfect circles. I know. So hard to pretend that because I am such a great artist. But yeah. A full sphere will always create a perfect circle. A hemisphere will not. Not a perfect circle. Okay, so that is a hemisphere. Nate, what's the formula for the surface area of a hemisphere again? Nope, that's full sphere.
2 pi r.
That's the bowl.
Plus.
Plus an additional pi r squared making?
So 3 pi r.
3 pi r squared, thank you.
Yeah.
Yep, that's the one we wanted. Charlie, what about volume? Nope. Not 4/3. 2/3 pi r to the power of 3. Write down your formulas. If you get nothing else on your notes, you better get your formulas. Haley, what's our radius? 18. That does go from center to edge, so that is the actual radius. Once you identify the radius, what do? You plug it in. We're going back to Glade commercials. Plug it in, plug it in. Thank you. I needed that. I didn't need that, but that's okay.
What would you plug Febreze into?
There's Febreze plugins.
Oh yeah.
There are Febreze plugins. Greta, what do we get for surface area? Point what?
6.2?
Point what?
6.
Point what?
6.3.
There we go. If there's no units, what do I put? Units squared or U squared for units.
Miss Benson, you should teach everybody how to power off their calculators.
Most people know how to find the power button.
I figured out how to turn it off.
I don't know how to turn
Everyone knows how to
Good
turn
job,
off their
Dominic.
calculator. And if you don't know how to turn off a calculator,
Dominic, what do you get for volume?
I don't know how to turn
If you don't know how to turn off your calculator, I will be happy to show you the work.
I just learned that yesterday.
I know.
I had to click the abacus.
Good job, Colin.
12,214.51.
Units. Cubed. Trout, be on your own. Every single one of you. I'm going to do it up here so it gets in the recording quick, and then I'm going to be coming around. Cam, do some math. I've nicely left the formulas up on the board for you.
Ooh la la la. Good, good.
Yes. Other than that little bit around that we were doing. You forgot to put the pie. How does that roll? Double check your
Yeah, that's
I'm literally talking about doing the notes we're doing right now.
Good night.
Yes, we gotta do it.
Sit on the track. Quickly, make that. Oh. Double check the routing on that. There we go. Beautiful, love it. Beautiful, love it. Beautiful, love it, but we know what the units are. Oh, and double check your rounding on that. Beautiful.
should be.
Yes, we are doing the back page. The 22 is not the radius, but the diameter. Half of 22 is 11. So 11 is our radius. When we plug that in, we should get 1140.40 if we're rounding correctly, meters squared. And for surface area, 2787.64 meters cubed. We do have one more page that we're talking about today. Make it fast. What do you notice about question C? It's got what? Huh?
Pi.
It's got a pi involved. True. What else?
No radius.
No radius. What else? It has a circumference and it's a sphere, not a hemisphere. We did one like that already. But please, do pay attention to what shape it is. We are skipping that problem though. So, the last thing you're going to see are the working backwards problems. I want to find the radius on this one. So, looking for radius. What shape? That's a full sphere again. Do I want the surface area or the volume formula? Surface area formula. Surface area for a sphere. Ava, what is the formula?
4 pi r squared.
Yes. I almost said no, but then I was going to be wrong. Surface area is 144 pi equal to 4 pi r squared. I'm going to leave r because that's what I'm solving for. Do you notice there's a pi on both sides?
Yeah, cancel them out.
They can cancel out because if I go and divide by the pi right now, those might as well just disappear. Oftentimes I simplify first. Can you simplify things first? Absolutely. Is it going to make it harder? On this problem, yes, because of the pi's. If it didn't have a pi, then I'd be doing some simplifying. Kylie, what should I do now? Divide by 4. 36 is equal to r squared. Biji, what do I do next? Find the square root. Do I need the plus or minus that goes with square roots on this problem? No. 6. What's? Centimeters. It's a radius. Next problem wants the diameter. Is it a sphere or is it a hemisphere? It's a full sphere. Surface area or volume formula? I'm given S, so I'm going to use the surface area formula, which Ava so kindly told us last problem. Generally, I simplify. The exception is if I see pi on both sides. On everything, that is.
Cancel them out.
They will cancel out. If you want to simplify first, you can.
And whatever radius ends up being, then it's just double that, whatever the diameter is.
Yes. How do I get the radius, though? What do I have to do now? 5 by the 4. 5.26 06 equals r squared square root. .25. Again, this one's centimeters. So the work backwards problems on these ones. Oh, wait a second. Am I done?
It's 4.5.
I forgot. I want diameter. Since the diameter is 2 radius, I double that and I get 4.5 centimeters. My bad.
I even told you that that's not
I
simple.
know. I know. I did stupid things.
We're almost done now. Last problem. Hemisphere has a surface area of 147 pi meters squared. Find the volume.
Looks like we're using the volume formula.
No. But it gives you surface area.
Oh, yeah.
It gives you surface area, which means I'm using the surface area formula. But what shape is this one? A hemisphere. So the surface area formula is not 4 pi r squared, it is 3 pi r squared. So 147 pi equals 3 pi r squared. Do I simplify first to get rid of the pi? Get rid of the pi. When there's a pi on both sides, I do that first. 147 equals 3r squared. Guess what?
We're gonna divide.
We're going to divide. It's very similar to the previous problem. R squared is going to be equal to 49. Square root.
R equals 7.
Radius is 7. Is that what we were solving for?
No.
We're solving for volume. I now have the radius, so now I can plug into the volume formula. Colin was not wrong here earlier that we used the volume formula. We just didn't use it first. What's the volume formula? 2/3 pi r cubed. .38 units. Meters cubed. So, on these ones, when you work backwards, you might have to work backwards just to get the radius, to get you things like diameter or a volume. Y'all know what's coming next.